Hello students. Today I'm going to teach you the very first chapter of class 9 physics, measurement and experimentation. As you can see in the title of the chapter, the word used is measurement. Thus I'm giving you first of all the definition of measurement. It is the process of comparison of the given physical quantity with the known standard quantity of the same nature. Means measurement is basically the comparison of the given physical quantity with the standard quantity of the same nature. Now, the word used in this definition, which is new for you all, is physical quantity. Physical quantity is basically the property of a system which can be quantified by measurement. It means any quantity which we can measure is known as physical quantity. Like mass is a physical quantity because we are able to measure the mass. Length is also a physical quantity because we are able to measure the length. We are able to quantify the length by measurement. The another term which is used in this definition is the standard quantity. The standard quantity which is used to measure the given physical quantity is basically called unit. The standard quantity is basically called unit. So the next definition which I am giving you here is of unit. It is the quantity of a constant magnitude which is used to measure the magnitude of other quantities of the same nature. As we know that every physical quantity can be measured in a particular specified unit. Like if we have to measure mass, which is a physical quantity, then its unit is definitely be kilogram. Similarly, length can also be measured and its unit is always meter. So, unit is the quantity of constant magnitude which is used to measure the magnitude of other quantities of the same nature. These two will be basically required to express any physical quantity. Means a numerical value and a unit is basically required to express any physical quantity. For example, if I say I have to measure the physical quantity mass and I say the value of mass is, for example, 5 kg. What does it mean? It means the numerical value of this physical quantity mass is 5 and the unit which is used to measure this physical quantity mass is kg. Thus, in order to express the physical quantity mass, we require the numerical value, which is 5 over here, and kg, which is the unit for the mass. Now, the next topic is choice of unit. What properties the unit should have on the basis of which we select the unit? The first requirement is that it should be of convenient size. Means the size of the unit should not be too large, it should not be too small, it should be of convenient size. The second thing which is required is it should be reproducible. That is, it can be used repetitively to retain the consistency of unit. The third thing is the value of unit should not change with the space and time.  'Means the value of the unit remains same. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. 'Means the value of the unit should not change with the space and time. ' It doesn't, the space and time doesn't affect the value of unit. And the last requirement and the property is it should be possible to define the unit without ambiguity. Here the ambiguity means uncertainty. There should not be any kind of doubt in defining the unit of a physical quantity. So these are the properties of the unit which should be which are required. Now the next topic is kinds of unit. Basically there are two kinds of unit. One is the fundamental and basic unit, and the second one is the derived unit. I will explain you one by one. The first one is fundamental or basic unit. It is that which is independent of any other unit, or which can neither be changed nor can be related to any other fundamental unit. Means those units which are not dependent on any other unit. They are independent. For example, here I have given you one example. The unit of mass. Mass is a physical quantity whose unit is a fundamental unit. The another example is unit of length. Another fundamental unit is unit of time. Another example is temperature. Another example is current, amount of substance. These quantities, the unit of these physical quantities are the fundamental units. Means they are independent of any other unit. So, if the fundamental units are asked, then we have to give the example of unit of mass. Unit of mass is kilogram. So, kilogram is the fundamental unit. Unit of length. Unit of length is meter. So, meter is the fundamental unit. And these mass, length, time, temperature, current, amount of substances, these are the physical quantities. These are the fundamental physical quantities whose units are fundamental units. Now the next thing is derived units. These are those which depend on the fundamental units or which can be expressed in terms of the fundamental units. For example, if we have to find the unit of area, then for finding the unit of area, we require the unit of length and breadth. Because we know that area is equal to length into breadth. Area can be expressed by the formula, by the definition, length into breadth. Now, what is the unit of length? Meter. What is the unit of breadth? It is also meter. It means the unit of area is dependent on the unit of length and breadth. Thus, the unit of area is a derived unit because it is dependent. Similarly, we can take another examples of volume and speed. Like if I explain you about the speed. Now, let us give you the definition of a speed. Speed is distance upon time. Now, the unit of distance is meter and the unit of time is second. It means the unit of speed cannot be directly calculated. It is actually dependent on the unit of distance and time. Unless we don't use the unit of distance and time, we are not able to find the unit of speed. Thus, speed is the unit of speed is a derived unit. because it is dependent. Whereas distance and time, which is used in the formula, they have the direct units. So these, the unit of distance and time, are the fundamental units. I guess the topic is clear to you, and I have given you the assignment based on this only. Kindly complete the assignment till I give you the next video. Thank you.